Distributed caching is a technique used in distributed systems to improve performance and scalability by storing frequently accessed data in memory across multiple nodes. This helps reduce the load on databases and other backend systems, as the data can be quickly retrieved from the cache. Here are key concepts and considerations related to distributed caching. Key concepts. Cache. A cache is a temporary storage area that holds a copy of frequently accessed data to speed up subsequent requests. Distributed cache. In a distributed caching system, the cache is spread across multiple nodes or servers, allowing for greater scalability and fault tolerance. Cache invalidation. Strategies for ensuring that the cache stays synchronized with the data source. This involves removing or updating cache entries when the underlying data changes. Cache coherency. Ensuring that all nodes in a distributed cache have consistent data. Techniques such as cache invalidation and cache synchronization are used to achieve cache coherency. Eviction policies. Rules or algorithms used to decide which items to remove from the cache when it reaches its capacity. Common eviction policies include least recently used (LRU) and least frequently used (LFU). Partitioning. Distributing the data across multiple cache nodes to prevent hotspots and uneven distribution of load. Considerations for distributed caching. Scalability. Distributed caching should be designed to scale horizontally, allowing for the addition of more cache nodes to handle increased load. Fault tolerance. A distributed cache should be resilient to node failures. Data should be redundantly stored or replicated to ensure availability even if some nodes go down. Consistency. Maintaining consistency across cache nodes is crucial. Techniques like cache invalidation or cache synchronization, e.g., using a distributed cache protocol like Memcached or Redis, help achieve consistency. Data partitioning. Decide how data will be partitioned across cache nodes to avoid hotspots and distribute the load evenly. Cache synchronization. Ensure that updates to the cache are synchronized across all nodes. This is particularly important when using a distributed cache with multiple instances. Cache expiration. Set expiration times for cached items to ensure that stale data is not served. This helps maintain data freshness. Monitoring and metrics. Implement monitoring tools to track cache usage, hit rates, and other relevant metrics. This helps in identifying performance bottlenecks or issues. Examples of distributed caching systems. Memcached. A high-performance, distributed memory object caching system. Redis. An in-memory data structure store often used as a cache, database, or message broker. EHCache. A widely used, open-source Java-based caching library and standalone caching server. Hazelcast. An open-source in-memory data grid and caching solution. Apache Ignite. An open-source distributed database, caching, and processing platform. Distributed caching plays a crucial role in improving the overall performance and scalability of applications, particularly in distributed or microservices architectures. However, it's essential to carefully design and configure the distributed caching system based on the specific requirements and characteristics of the application.